Hello. Hi, everyone. Welcome back. Thank you for joining us back in the auditorium. Hope you all had a good lunch and good networking. So we're excited to bring to you today another session of Lightning Talks, this time featuring people from around the world. So this is a special session of virtual Lightning Talks, similar to what we do at the EarthEngine virtual Meetup. So today we are having a special moderator for this session, Sheryl Reyes, who is the president of the ISPRS SC, which stands for the International Society for Photogrammetry and Remote Sensing Student Consortium. So I'd like to welcome Sheryl to join us, as well as our distinguished speakers and Lightning Talk presenters. So I'll let Sheryl take it over from here. Thank you, Sheryl.
Thank you, Sabrina. Hi again, everyone. My name is Sheryl from the ISPRS Student Consortium, and I welcome you all to this afternoon session of Lightning Talks. So I will be your moderator for this session. So I'll start by sharing my screen so that I can show you our list of presenters. I hope everyone can see my screen. So for this afternoon session, we have 4 presentations. So again, we'll have 5 minutes each for every talk, and we'll have the question and answer session at the end using Slido, which I think Sabrina already introduced to you earlier. So without further ado, we are going to have our first presenter, who is Zaib Un Nisa, on the talk on evapotranspiration, an important indicator for water stress in Mediterranean Basin. Zaib?
Okay, over to me. Good afternoon, everybody. So I'm going to talk about evapotranspiration as an important indicator for water stress. I'm Zaib Un Nisa from University of Molise, Italy, and EarthEngine in my study area and also in my field. Next. So Mediterranean Basin is basically a hotspot for climate change. You can see in the temperature graph. Nowadays, in the recent decades, we are observing that the temperature of the Mediterranean region is also exceeding like over the globe. And in the precipitation anomalies, we are also observing the fluctuations in precipitation, which is also having some seasonal effects. We are getting less rain over the region. We are observing the drought frequencies and the warm spells, and which is also affecting the livelihood systems in the hyper-arid region, especially in the North Africa and Middle East part, and also the Spain. Next, please. So how we relate climate change with evapotranspiration, because evapotranspiration is based on temperature and vapor pressure deficit. So atmospheric water demand, it's basically an atmospheric water demand, and we deduct using meteorological information and also the land surface parameters. This is how we put this information in energy balance equation. For that, we use energy balance model. These energy balance models solve the energy balance equations, where you consider that the amount of the radiations that a system is receiving, it is also giving back in the form of latent heat flux and the sensible heat flux and the ground heat flux. For that, we need surface parameters. So we use remote sensing data in that, and whatever we retrieve, we compare with the ground-based data. We have different methodology for that. Like, for example, we have different instruments, lysimeters, eddy covariance systems installed. Next, please. So based on this concept, I developed another study, a study on southern Italian site, where I will tell you about how I use Google EarthEngine. Next. So this is the picture of the site. It's a rotational cropping system containing maize, alfalfa, and some winter grass. You can see how it's being managed. It's a central pivot irrigation system, and it has an eddy covering system installed for the ground data. Next, please. This is the entire methodology of my study. I use Landsat data, and there were some points where we have to use de-stripping the data and do the gap filling things. Then I did all my data processing on Google Earth Engine for the retrieval of all the surface parameters like vegetation indexes, emissivity, albedo, calculation, fractional cover, vegetation. So the benefit of using is that like you can retrieve all the information about the surface, and then you put in your open source application. Based on that, you can retrieve your information easily. So it's really helped me out, and it's really a good substitute for me instead of using other software-based applications. Next, please. So, as I already explained about the energy balance model, this scheme is being widely used globally now, and we have different applications, different energy balance models that have been implemented in the cloud sources. One which is highly related with Google Earth Engine is the EE-Flux metric model is implemented on Google Earth Engine, and it's really a competing application with the other cloud sources like GlowDat or Vapor application and OpenNet. So this is how it's really helping to the globe as well. Next, please. Using the Google Earth Engine, I developed another study quickly. It's about doing the water balance analysis over the whole basin. And previously, I showed you my plot scale study, and now I'm going to tell you about the regional scale study. I used 30 years climate data and calculated the water budget over the basin. Next, please. So what is water? How do we calculate water budget? We basically take the all information about precipitation, runoff, and evapotranspiration. We subtract them from precipitation. We subtract the runoff and evapotranspiration, and in the end, we get the amount of the water that is stored in the soil and in the reservoirs. Next. So there are plenty of resources and the repositories that are embedded in the Google Earth Engine. You can retrieve TRMM, GPM, GLDAS, FLDAS, MODIS products, and TerraClimate products where you can retrieve precipitation, evapotranspiration, runoff, and all the parameters that are basically used for water budget calculations. So I used, and you can see how the different temporal and the spatial resolutions are available for you to process the data, which is really a good substitute for even for the in situ observations. If you don't have in your area, you can apply that. Next, please. So because my next, please, you can show the more text on the slide. Yes. So based on that, I used 30 years span from 1990 to 2020, and then I calculated the water budget equation over that. And I used TerraClimate data and also the land cover information, the updated land cover information to understand what is the situation. Yes, next please. So this is how I calculated the average precipitation, actuality, and the runoff. And in the end, next please, I got the product where you can easily understand where is the water deficit and where is the surplus water available over the basin and in the different land use systems. Next please. This is another thing that nowadays it's really easy. You can apply, calculate the agricultural water productivity of the basin, and I use Nile data for that. I use different ET products and then compared their productivity using different data sets, and I got the different products. So the concept is Google Earth Engine is really good for you to retrieve maximum information as you can, and for the comparisons. Next. With this, I conclude that it is really an emerging factor now, and it's being applied. I showed you 3 examples how it's been actively applied, and how the Google Earth Engine is supporting in this plethora. We are really expecting using the machine learning concept and cloud computing concept, which also embedded, the algorithms are also embedded in Google Earth Engine, and then we can really do some crop ET behavior analytics on that. I see that in my application, Google Earth Engine can be maximally used. This is how I conclude my presentation here. Thank you for listening.
Thank you so much, Zaib. Now we'll go to Laxmi Goparaju's presentation on forest fire emissions analysis in Uttarakhand, state of India, using Google Earth Engine. Lakshmi?
Yes, thank you, Sheryl. Good afternoon, everyone. Myself, Laxmi Goparaju, along with my co-authors P. Ramachandra Prasad and KV Suresh Babu, I will be talking about forest fire emission analysis in Uttarakhand, which is one of the states in India and is more vulnerable to forest fires. Next slide, please. This is one of the states of India, Uttarakhand. It is in the northernmost region. It has 13 districts, and these are Tehri Garhwal, Pauri Garhwal, Almora, and Nainital. These are the most fire-prone, forest fire-prone areas. So today I will be talking about Pauri Garhwal and Nainital. So these two districts have the highest forest cover. Next slide, please. So Uttarakhand in 2021 recorded a 28.3-fold increase in forest fire incidences between November 2019 and June 2020 and November 2020 to June 2021. Next slide, please. The objectives of this study were to study the forest fire emissions for the pre-fire, fire and post-fire period. The pre-fire period was chosen was September 2020, when no fires were reported. Fire period was from February to May 2021 and post-fire period was from June 2021. The variables chosen for the study were aerosol absorbing index, carbon monoxide and nitrogen dioxide. So spatial variation of forest fire emissions in the two forest dominated districts was also studied. Next slide, please. The satellite data used was Sentinel-5 precursor, which was launched in 2017 by the European Space Agency, mainly to monitor air pollution. The multispectral sensor of tropomy instrument is capable of recording reflectance of wavelengths vital for measuring atmospheric concentrations of methane, formaldehyde, aerosol, carbon monoxide at a spatial resolution of 0.01 degree arc. In this analysis, vertically integrated carbon monoxide column density and nitrogen dioxide column number density were used. Next slide, please. So the shapefile of the districts were ingested in Google Earth Engine, and then the image collection of the respective variable was called upon, and then we segregated it or filtered it according to the date and time into three classes like pre-fire, fire and post-fire, and then the data was clipped according to the district boundary. So this one is district Garhwal aerosol absorbing index. So we can see the differences between pre-fire, fire and post-fire time periods. Next, please. This one is district Garhwal carbon monoxide. Again, pre-fire, fire and post-fire time period. So we can see during the fire period, the whole of the district is quite affected by carbon monoxide. Next. This is nitrogen dioxide, again for the three time periods, that is pre-fire, fire and post-fire. So the differences are quite visible during the fire period. Next. This is district Nainital. Again, this is pre-fire, fire and post-fire period. So in Nainital, again, we can see that the emissions are making a difference during the fire period. Next. This is carbon monoxide, again the district Nainital for the three time periods. So for the fire period, we can see the values are increasing and are quite high as compared to the other two time periods. Next. This is aerosol absorbing index, and again for the 3 time periods. So aerosol absorbing index is dimensionless. The positive values indicate that the presence of aerosols in the atmosphere. So we can see towards the southeastern region of Nainital, it is highly affected. Next. For aerosol absorbing index, the maximum emissions were noted in district Nainital, followed by Garhwal. For carbon monoxide emissions, most affected district was Nainital, followed by Garhwal. But for NO2 emissions, the most affected district was Garhwal, followed by Nainital. So Google Earth Engine had facilitated me to study at regional scale and in a very short interval of time, and to observe the temporal as well as the spatial variations, which otherwise would not be possible at a very less time, and the extent also. So Google Earth Engine is very useful in studying the forest fire emission, especially in areas where hilly areas. Actually, Uttarakhand is quite hilly and mountainous, and uh, fire stations or fire monitoring stations on ground are not very not available. So this Google Earth Engine data helps us to have a good and overview of the fire areas so that mitigation efforts can be take place. Thank you.
Thank you so much, Lakshmi. Now we proceed to the next presentation on open source projects for EarthEngine in Python, R, JavaScript, and Julia by David Montero Loaiza. David?
Hi, Sheryl. Thank you very much. And welcome everyone to this lightning talk. I'm David Montero Loaiza, and I'm going to talk about some open source projects for EarthEngine in Python, R, JavaScript, and Julia. And this open source project is more like resources for you for creating scripts, for creating code in order to do some kind of analysis inside Google EarthEngine. So for example, in next slide, please. You can see here some of the EarthEngine extensions in the top right corner. You can see the EarthEngine API that is originally created for Python and for JavaScript, and maybe you have used more of the code editor also in Python scripts, like in Jupyter notebooks or something like that. So people in the community has created a lot of extensions for more people in the community to use scripts inside Google Earth Engine. So for example, we have Gmap for interactive mapping with Google Earth Engine in Jupyter notebooks. But for example, for people that use R, RGEE was created so you can use Earth Engine inside R. That is the same for QGIS with the QGIS Earth Engine plugin, and also for new languages like Julia, where CareMarket has created the Earth Engine package. So you can use actually Earth Engine in a lot of programming languages. And next slide, please. And this has been like the start of creating like a new ecosystem for unifying all this. So let's start with Python. For example, here you have a common Earth Engine Python code. For example, if you have an image collection, in this case is Sentinel-2, you want to map a lot of functions over it, like cloud masking, scaling the values, adding some spectral indices. This is the common Earth Engine Python code that you have to develop in order to process your image collection. So click, please. So we created a more intuitive code, in this case for Python. This is the EEMON Python package that sends the Google Earth Engine API in Python. And this, the code in the right makes exactly the same as the code in the left. And as you can see, it's more intuitive, more short, so it's easier for the community to make scripts using this kind of code. But the idea was not just to stop here in Python. So next slide, please. We created the EEXGA ecosystem. This in collaboration with a lot of people, including Cesar Baker-Marshall, who is the creator of RGE. And we created EEXGA. EEXGA, it's a Python package that has a lot of functions of methods for analysis, for processing, preprocessing, of image, of vectors, etc. And from that Python package, we created extensions packages for Python, in this case, is EEMOD, and for R, that is called RDEE extra. And then you can use these packages inside each of the programming languages, so you can use these new methods that are more intuitive, are more easy to create. And that's not all. Click, please. You can also use them in QGIS and in Julia, so you can get the benefit to use this ecosystem, not just in the original API of Python and maybe with the extension in R, but also you can use that in QGIS and Julia. Next slide, please. And here you can see an example of how EExtra unifies the EarthEngine ecosystem. You can see that for Python, you can use EEMOD to use these functions, these new functions that are easier and simple. And you can use RDE extra to use it, to do exactly the same, but now inside R. And it does not end there, because if you combine EEMOD and the EarthEngine package in Julia, you can do exactly the same that is done in Python. As you can see, you can do it in Julia by using Julia code. And it's the same for R. If you use EEMOD in R, you can get exactly the same snippet of code with the same functions. Next slide, please. And as an experimental, we are also trying to get the JavaScript modules to the rest of the ecosystem, because as you know, in the code editor, you can create your own modules and you can call them, require them, and use them inside the code editor, but you can't use them outside there. So we created like a translated module that actually takes the modules from the code editor, from the JavaScript API, and translate them to codes in Python and in R. And by extending the ecosystem to Julia, you can also use them in Julia. But this is an experimental feature that we are testing. So we hope that at some point in the future, you can use JavaScript code inside Python, R, and Julia. Next slide, please. And this is the end. Thank you very much. This was not just done by myself, but by a lot of people. And I want to say that contributions are also welcome to this ecosystem and project. Thank you very much.
Thank you, David. And finally, our last presenter is Matthew Gravy, who will present the Open EarthEngine Toolbox.
Hi, everyone. So the goal of this work is to provide extra tools, but this time in JavaScript. So you can see it as a complementary of the previous talk. My target is only in the browser. Next slide. Next one. So the tools is in two parts, a library and a Chrome extension. So the library provides like code, and it do that using functions. Why we use function and not script is because it's very easy to port from one person to another. If we share like scripts, each time you request modification and so on, that it take a lot of time for people to use. So we design functions with harder to write, but that you can easily use them in a single line. Next slide. So how to use it? You just need to do a simple import, as it was shown before, which require. And after, the structure of the library is pretty similar to the EarthEngine structure. So you find process for image collection in image collection, for image in image, and so on and so on. And the functions are designed to work in the same way as native EarthEngines. That means that you can provide parameters dictionary or directly do a direct call with the different parameter function. So very transparent usage. Next slide, please. So today you have a bunch of functions. We are going like to very specific for some product like Sentinel or Modis, to very more generic computation like SG filter or O2 thresholding and so on. That's the list, maybe give one or two more since this screenshot was taken, but like that's the idea. And it provides some feature to export image like dictionary collections, if you want to do all collection export and so on and so on. But these features most of the time will require to use the extension to get full potential. Next slide, please. So each function is provided with a documentation online. and most of them with a small example where you can check how to use them. Just like give a website with all this documentation is really again in the G style that you are not feeling lost when looking on it. Next slide. So if you want to contribute, you are welcome for sure. The contribution, you just need to download or to click on the link to the template on the documentation website. You make your function, you test it, and once it's working, you just go to the GitHub and submit it. And if it works, I will be happy to accept it. Everything else is automatic. GitHub will automatically synchronize it with Google Earth Engine to make it available for everyone. Maybe take an hour or so, but that's the idea. Next slide. I try to make it very handy to work and to contribute by making a single file for each function. So if you contribute, you can write everything in a single file. The documentation, the function, everything, it's in one place. It's easier to maintain too. And each function is on I mean, if you contribute to a function, just add your name on it. The license of the library doesn't conflict with the license of any function. So if you provide a function with a specific license because you want it, it's not a problem. It's okay. It's okay for us. We don't really care. It's your freedom of this. Next slide, please. And now what's coming more is an extension because some stuff cannot be managed directly from the library itself. Next slide. So this is a Chrome extension that currently, okay, maybe some use or more since this screenshot was taken, but it's an extension that you can simply install in Chrome by going on the Chrome store and just add it. Please, next slide. And it provides some quite nice features. The first one is night mode. I mean, if you're a night bird like me, your eyes will thank you. It provides some other features like uploading like files in batch or like with parameters to use a manifest to upload. It provides a button to import directly a signature of function and so on and so on. Next slide. And if people use Planet, it provides tools to search and automatically download or transfer Planet image from Planet to Google Earth Engine. You just search, making a geometry in your Google Earth Engine, select the image you want, press the button, and everything will be automatic. Next slide. That's it. And I would be curious to know what you are looking for, like maybe some function to do plot or like user interface for application. I'm very curious. Let me know what can be useful for you. Thanks.
Thank you so much, Matthew. That's our last presenter. And we invite everyone to send in your questions at slido.com. You just need to type in the code EESG. So from our audience in Singapore, I hope that you can give our presenters a round of applause for sharing their amazing work on Google Earth Engine and also sharing some incredible resources that could further help you in working with Earth Engine. So let me just stop sharing my screen so that I can share that Slido tab to see if we have questions from our audience already. So maybe just to start off, maybe our presenters, maybe can you share with us what was your motivation or what was your reason for using Google Earth Engine for your projects or for your applications?
I would say for me, it's the possibility that to do studies without the need of downloading the whole planet. I mean, everything is there. You can just press the button and access it. On the other side, we don't need a big cluster too. We can just like use Google resources to do.
Okay. So we have one question. So after identifying emissions from forest fire, how can we mitigate forest fires? So I think this would be for Laxmi.
Yes, thank you. A very good question. So for mitigation, the fire officials or forest fire, forest officials, they need to identify places where the emissions are high and how it is spreading. So they can note the regions you can visualize a whole district when you see the emissions. So you can pinpoint or you can focus on those areas where the emissions are high. So in that way, you can alert the public or you can evacuate the public or other measures can be taken which can reduce the influence or effect of forest fire emissions.
Thank you, Lakshmi. Any other questions from our audience? Okay, for Matthew, is it possible to have OEEL in Python?
Let me put the mic. That's a very good question. I'm already considering to do some like synchronization between both or communication. I don't think like translation as was proposed by David would work on it because the way the library was constructed is pretty like complex, and I don't think you can translate or transcript everything. I mean, if David has an idea maybe on this one, I mean, feel free to try. But I think we can maybe do one day some synchronization using like Node.js in background to do some computation. We need to be JS done and get directly the result. But we say that's work in progress, and we probably take time to figure out a way to make it work properly. So currently not. I mean, after, if you need a specific function, you can always go in the source code with like open and just go and transcript or just copy paste the part of the function you need.
Okay, thank you so much, Matthew. We have another question, I think, for Lakshmi. Regarding the fire study, were any hotspot or burned area images used to understand spatial distribution of fires?
Not in this part of the study. This study was only focusing how to study the forest fire emissions. It can be used, I think Climate Engine, which is also again a part of Google Earth, has a lot of capabilities to study the burned area images and also understand the spatial distribution. Thank you.
Thanks so much, Lakshmi. And for David, just a curious question. Why did you call the package EEMont?
That's a really curious question. Well, I call the package EEMont just because of EarthEngine and Mont are like my first letters of my last name. So that's it. That's the reason.
Thank you so much, David. And another question on the hydrology work. What is the purpose and use of EE flux? I think this would be for Zaib. Zaib, are you still there? Hello? Okay, so maybe for the meantime, we'll skip the hydrology question and I'll move on to the next one. So this is for Matthew and David. What inspired you to create your own tool and combine open source tools? And what are other needs you identify lacking in G?
So for me, I mean, most of these tools were created during my PhD, and they were just lying around in some script or like personal package stuff. And I was spending so much time to send it to each people. Like, you know, some people contact me, yeah, you have an idea. Oh, yeah, I have a script to do that. Let me send you one. And after we like struggle because whatever stuff is not well supported or whatever. And so I decided that it's time to make it like more shared. And I make a structure to put it in, and after start to put function in. And for the extension that exists even before the library package in my PhD, because I needed to transfer this planet image that is at the origin of these tools. I mean, I planned to share it since a while ago, but it was not easy to do some limitation or restriction from the Chrome store. But with the new version of Chrome extension who appeared last year, it was suddenly easier to share it. And so I was happy to do it.
Thanks, Matthew. And for my case, it was because Google Earth Engine has a lot of potential. I mean, there is a lot of people working in geospatial stuff, and Google Earth Engine is like another software for it, but a really powerful one. You can use it as GIS as processing base for raster and for a lot of stuff. You can even do machine learning, and the potential is so big that you want to extend it. I mean, you can use it in JavaScript. That's okay. That's of course very good. And using it in Python, it increases the possibility to use third-party packages. And if we want to use other things that, like for example, Julia, it's an emerging language for high performance in scientific computing. And if we want to use all the capabilities of Julia, now we want to extend this potential of Earth Engine to this kind of languages. Also, for example, R has a big geo user base. And we want to address that. If there is a lot of people using geospatial processing tools in R, then why don't we extend this to R, to the community, so the people can actually use the potential of Google Earth Engine? That's my answer for this.
And maybe in lacking stuff in Google Earth Engine, I mean, we need to get that it's still like something we constructed, is like in permanent evolution. And if we look like major evolution over the 5 last year, I mean, it's like crazy what we can do today. Missing stuff, I would say a nice plotting library. That's something like sometime I went quickly to visualize stuff, and after I've like 5,200 points, and you say, no, maximum 5,000, stuff like that. Or like you want to visualize quickly a 2D, and it's harder to export a quick map. I mean, it gives tools to do stuff, but you want to export quickly a map in some projection to put in a paper. Each time it requires some effort, where we could imagine something a little easier.
Thank you so much, David and Matthew. I think everyone can agree that the resources that you have provided for us would be very, very useful to many users of Google Earth Engine. And can I just check if Zaib is here? Zaib, are you here? Okay, so I think if she's not here, maybe we will just pass on the question to her, and maybe she can respond via email. So I think there's one more question. Can you describe your journey into programming an Earth Engine? So this is for our speakers, to anyone who would like to share their experiences.
I can go for this one. Maybe in my case, I am not from for example, from a background of computer science or something like that. My background is geomatics, and we didn't have actually some like big background in programming, so I started with something simple. I started with R. R is a very simple programming language, and after that you can go escalating. Then you start with Python, JavaScript, etc. And I started using, for example, in R the raster package to manipulate satellite imagery, but believe me, when you know EarthEngine and you know how easy it is to manage it and how easy it is to do analysis and processing and everything in the cloud, and you don't have to download stuff and all the catalog inputs are there and you can just grab them and do your analysis, that's very exciting and nice. So if somebody wants to actually start with that, it's very, very nice.
For me, so I need to say, at the origin, I'm like a computer expert. I mean, I have HPC, high performance computing. It's my field of study. And I moved to geoscience for my PhD. And so for me, like EarthEngine is really synced in a very cloud-based approach. So it's very easy for me to understand how it's working behind and how to make efficient code in it. So it was quite straightforward for me to move to EarthEngine. I started with like Pascal at the time, with a very awesome language to start to learn to program, but only for a few months. And after I moved to like C and JavaScript and Python, and typically I hate R. But yeah, I don't think it gives like a way to go in programming. Everyone has his own way to go in. I just think you need to have a project to go move forward. Same to learn EarthEngine. I mean, okay, it's great to follow tutorials, but you need to have your own project to get the motivation, to keep motivated on learning and solving issues and so on and so on. So yeah, and for the question about if we are, I mean, if I plan one day to make it payment, no. I mean, currently I'm lucky to have like an academic position, so I can spend some time on this project without the need of asking money. And I think it's quite important. I mean, Google leave it is using it for free too. So it's, let's say, my contribution to the community to make it free to mine.
Yes. If I describe my journey into programming, I would say that I'm also a novice in Google Earth Engine, but I don't have a background in computer or programming language. But the potential that Google Earth Engine has so much that it attracts you towards it. So after you start exploring it, you start discovering also, and you start learning also. So another question which is there, what advice would I like to give to the researchers looking to the Earth Engine? I think for your research, Earth Engine has a lot of potential to provide the researchers, and the biggest thing is it has a lot of data. So much has to be explored, and every day new data is also getting ingested into it. So keeping a track of it and you discovering and innovating. There are so many apps a person can develop by learning from tutorials itself, and there's so much to learn and so much to give also to Google Earth Engine. Thank you.
Thank you so much to everyone. And thanks, Laxmi, for answering the next question. Maybe I'll just ask David, because this is also a question maybe for you. That's a lot of hard work. Do you guys plan to monetize your hard work? If yes, then how?
Okay, for starting, these projects, EMONT, these things are open source, they will remain open source. I mean, science should be open. And the idea is that people from the community, from everywhere in the world can actually use them without any limitations. So they will remain that way.
maybe if I can add on this one, I mean, if we imagine something very collaborative, like where many people are working on the project to make it better, it's start to be very hard to imagine a payment system behind, because how would you distribute the money and everything? So I think for the good of the project too, it's very important that it stay free.
Okay, I think that's good news for many of us. Okay, so for Laxmi again, is there another platform besides Tropomi for a better representation in spatial resolution?
I would say yes. Copernicus has a lot of satellites. There are a whole lot of satellites. I can't name them right now, but they can be used. But the difference is in acquisition of data and how to understand that data, like netcdf files and other things are there. So how to go about programming in Python, and how to acquire the data as well as read the data and then do the analysis. But Google Earth Engine has JavaScript, which is much easier to understand for beginners, and it is much easier to visualize also. So that is one important advantage which I have in Google Earth Engine. So if you are good at programming, you can go for Python. There are several Jupyter notebooks which will help you in studying the satellite data, which is hosted by Copernicus. Thank you.
Okay, thank you very much. Any final questions for our speakers? Okay, so I think our audience have already asked all their questions for our speakers. So I guess this is time to wrap up the lightning talks this afternoon. Again, thank you very much to our speakers, David, Matthew, Laxmi, and Zaib. We are very honored to hear all these applications and resources on Google Earth Engine, and I think everyone will find them very useful. So I hope that everyone will again give our presenters a round of applause from Singapore. So thank you very much. And thank you. Okay, that's nice to hear, or hearing the applause. Thank you so much, everyone. And since I can't be in Singapore, I just wanted to extend my congratulations to my co-organizers for, again, organizing a successful virtual and in-person meetup for this Earth Engine at SG. Thank you so much, Janice, Dawn, Minerva, and Sabrina, and to the Earth Observatory of Singapore, and to everyone in NTU. Sabrina, back to you.
Thank you, Sheryl. Thank you again as well for moderating this session and for getting all the questions to our speakers. So thank you again for the time you've taken to make this session possible. And thanks once more to all our speakers. So I'd now like to invite Janice and Dawn back on stage for our next session, which is the closing session.
Okay, sure, yeah. All right, so thanks everyone, and also our virtual participants. Actually, we've already reached the end of our program. I just want to thank all of you for being here. I think this afternoon session, we really hear from our in-person attendants, you know, the diversity of folks who are here, people who are coming from many different countries, and also being here and presenting about, you know, what they are doing, our interests during the lunch sessions and also networking sessions led by Dawn. So that was very helpful, I think, for us as organizers to also know what the interests are and also how we can move forward from here. So I think, you know, we pretty much have come to the end of our program. And we would like to invite you guys to come on stage to have a group photo before we end the session. And then we will probably just end it from here. So thanks so much. And I think maybe we could ask Aisha to help us to take a photo. Yeah. Oh, sorry, we have a photographer, so Aisha, you can come on board as well.
So in addition to thanking every one of you as well as our sponsors for making this event happen, we also like to thank Aisha for the wonderful work she's done in making all the logistics happen. Thank you so much, Aisha. And also to the CITS team at the back who have been making our audio and our visuals work. Thank you so much as well. So a big round of applause also to Aisha, the CITS team, and our photographer. Thank you, everyone. So please give them all a round of applause. And now we can get ready for the group photo.